Okay, can you hear us? Yes?
Yes.
It works too?
Okay, good.
Before we start our talk, I just want to let you know that we have a .NET developer survey. We are basically trying to understand what .NET people are doing in the cloud and asking you questions about Google Cloud as well. So if you have time, we would really appreciate if you can fill it. There's a QR code as well, and we'll also put this link at the end of our presentation. So if you want to do it later as well, please do so. So I'll just keep this up for like a minute, and then we'll start the talk after that. Oh, there he is. All right, I think everyone probably got the links. So let me start the timer. All right, so this is a talk that we're going to talk about, like Google Home meets .NET Containers. My name is Mete Atamel. I'm a developer advocate at Google. I'm based in London.
My name's Ian Talarico. I'm a software engineer at Google, and I'm based in Seattle, Washington.
Yeah, and then basically the premise of this talk is that we have this Google Home device, and we have some .NET containers running in the cloud, and we're going to talk about how do you connect this device to the cloud, and once you have the services running in the cloud, how can you make this device smarter by using machine learning and big data analysis? So we're going to go through an application that shows that. Actually, initially this talk came about because me and my coworker Chris, who is also here, we wanted to show our .NET libraries on Google Cloud, and we wanted to make it a little bit more interesting. So we said, OK, what can we do to make it more interesting? And then we realized that we had these Google Home devices, and we were like, oh, maybe we can use them, but we had no idea how to use them. We had no idea how to program them. So that's how we got into Dialogflow, which is a surprisingly easy way of programming these devices. And then once we got into it, we realized actually it's a good thing to talk about because it's very cool and it's very easy to do. So that turned into this talk, basically, and that's what we're going to talk about today. The application that we're going to show you, it's already on GitHub, and there are already instructions on how to set it up yourself and run it yourself if you want to. So that's the link for GitHub, and we're going to have the same link at the end as well if you want to take a look.
And you actually don't need a Google Home if you want to test out most of it. You can do it on Dialogflow, and Meta will show you kind of how that works later.
Yeah, I mean, as long as you have a phone, you have Google Assistant, you can use that. You can log into the account that you set up your project with, and then from your phone, you can test it out. So you don't actually need a Google Home device. That's a good point. So as I mentioned, this is a survey. If you want to help us out, please fill it. Thank you. And yeah, I'll let it.
All right, so this is the Google Home here. Quick show of hands. Who knows what a Google Home is? All right, this is the most I've seen at any conference. That's good. So for those of you who don't know, it's similar to Alexa. We have a test app running. So every time I talk to it, I don't have to say, let me talk to my test app. And then I'm also going to have to say goodbye. So I can't really explain stuff in the middle. So we'll go through a demo. I'll stop, and then we'll talk about what we did. So let's see if this mic is on.
Yes.
Yes. And I will give this a try. Hello, Google. Let me talk to my test app. It's not even on.
Maybe we unplugged it.
I think we unplugged it. Hello, Google. There we go.
Yeah.
Hello, Google. Do we bump the mic? Hello, Google. Let me talk to my test app. OK, Google. Let me talk to my test app.
I think it's picked up, yeah.
All right, getting the test version of my test app.
There we go.
Hi there.
Say hi.
Hello, everyone. Great to be here today at NDC in Oslo.
Goodbye. So I forgot how to talk to my device. Oops. So what we have here is the Google Home Mini, and it's talking to Google Assistant, which Meta mentioned before. And the Google Assistant, all it really does is it gets us connected to our test app, which is the Dialogflow you see up here. Dialogflow is the first time I've ever used it, actually, working with this application. It's awesome, easy to use. And a little bit farther, Meta will talk about it. The Dialogflow is then talking to Google Cloud Platform. Specifically, this application is running on Google App Engine, containerized service with Google. You can also have it run on Kubernetes Engine or any containerized version. We'll also demonstrate the Vision API and the BigQuery API. So these are like Google's big data and some of Google's machine learning stuff. On top of that, we'll also show you all the cool diagnostic stuff that we have on GCP, which is personally my favorite part.
OK, yeah, thanks for that. So I should first of all mention that we have to say, let me talk to my test app, because we haven't published the app yet. It's a test application, so that's why we have to say that every single time. But in real world, once you finish your application, you will publish it, so you won't be able to, you don't have to say test app anymore. You will just trigger your application with the keywords that you define. So that's the difference. You can use Google Assistant and Google Actions to program this device, but then there's also something else called Dialogflow that makes it even easier to program. So that's what we are using here. So when you look at the flow here, we go to Google Assistant. So when you talk, Google Assistant picks it up, but then Dialogflow takes it over, and then it will go through the Dialogflow. And you can handle these voice through Dialogflow directly, so you can actually have Dialogflow answer that directly. But you can also tell Dialogflow, go and pass this request to some other entity. In this case, it's Google Cloud. So you can create what's called webhooks and pass the request to these endpoints, and then these endpoints can do whatever it needs to do. In our case, we have a container, the Vision API and BigQuery that we're going to use. And then once you have the response, you can pass that back to Dialogflow, and it will say it. So that's the flow of our application. But just to talk about Dialogflow a little bit, first of all, anyone heard of Dialogflow or used Dialogflow? A few people, OK. Dialogflow is basically a developer platform to build natural and rich conversational applications. The cool thing about Dialogflow is that it works on any platform, so it has integration points with Google Assistant, with Messenger, with Skype, with Slack, and all these different places. It works on pretty much on any device, so on your phone, on Google Home Mini, on other devices as well. And it's global. It works all around the world, so it's not just US only or Europe only. It works everywhere, which is great. As I mentioned, Dialogflow has integration with Google Assistant. If you don't want to use Dialogflow, you can use Google Actions for that, but Dialogflow adds more intelligence on top, so that's what most people do nowadays, and it's the preferred way to program Google Assistant. And the coolest thing about Dialogflow is that it has built-in machine learning already. So for example, if you want to say, book a flight from Los Angeles to Hawaii for less than $300, Dialogflow will take this phrase, and it will pick up the fact that you have some entities in this phrase. For example, you have Los Angeles as the city, departure city. You have Hawaii as the city that you are arriving, and then you have $300 as the amount that you want to pay. And it will pick those as entities, and it will pass it to your application. So in the end, you will have a request that has the city, from, to as entities, and the amount as well, and then you can do whatever you want. And the cool thing about this is that you don't have to list all the phrases. You just list some sample phrases that you want it to understand. And from that, it will basically, anytime you say something similar, it will pick up on it. And the more you talk to it, the more it gets better and better, because it uses machine learning to train these phrases. So let me just show you the Dialogflow console for our application first. So here I am in Dialogflow. I log in with my Google account. First thing that you need to create is what's called an agent. An agent you can think of as a project for your application. You can have multiple agents if you want, but in this case, we only have one agent called Google Home Meets.NET agent. And you have some settings for the agent. For example, you can specify the time zone. You can specify there's different versions of the API, so we are using the latest API for Dialogflow v2. You can specify the languages, so by default, it recognizes English, but there's many languages that are supported that you can use. There's some settings for ML, but in this case, I'm using the default machine learning settings, but you can customize it if you need to. One of the cool things is that you can import and export agent. So let's say you have this agent, you train it, and you get it to the point that you like, then you want to share it with someone, you can export as a zip, and someone else can import it into their project and use it. So it's very easy to share if you want to. And there's a bunch of other things that I don't even know, like the environments and stuff like that. But basically, that you set an agent, and then you need to tell Dialogflow what your agent is supposed to do. And you do that through intents. In intents, you can have as many intents as you want. So there's some default intents, for example. So the default fallback intent is what happens when you say something to Google Home that it doesn't understand, right? So when you say something that it doesn't understand, it will use some of these phrases, like something like, I didn't get that, can you say that again? Things like that. So this is handled directly in Dialogflow. If everything fails, it will get here, and it will say these phrases. But you can customize this to whatever you want. There's also another intent called welcome intent. So this is what happens when you get into the application. So for example, when we say, let me talk to my test app, it goes to our application, and then it will say, hey there. So that's the response from our application. But obviously, you can customize this. So when we set greet users, or when we say hi to people, then it gets to this greeting.conference intent. So if you look at this, there are some training phrases. So when you say greet attendees, say hi to attendees. So all these phrases will trigger this intent. And things that are similar as well, not just this phrase, but any phrase that's similar to this will trigger this intent. And then the responses, we are just handling the response right here. So in this case, we are just saying a text response. Hello, everyone. Great to be here today at NDC in Oslo. So this doesn't go to Google Cloud. It just gets handled in Dialogflow directly. But then we also have other intents that we're going to show later. I just want to show you one of them. For example, we have an intent where we're going to say throw an exception, and it will get in here. But then here, the response says no response. Instead, we have a fulfillment, and it says a webhook. So the webhook is handled. So what this means is that it will get into this intent, and then from there, it will call an endpoint. And the endpoint is defined under fulfillment. And the fulfillment has a URL. So this URL, it's a .NET container running in Google Cloud. So it's just an HTTPS endpoint. And it will basically just pass that request to that endpoint, and that endpoint will handle it. And we'll show you the code for that later. And the last thing that I want to show you in Dialogflow is that, for example, if we look at BigQuery intent, in here, we have some training phrases for this intent. For example, what was the hottest temperature in France in 2015? So this is a training phrase. But as you can see, some of the words in the phrase, they are marked. They are marked as entities. And I marked them myself. So I said to Dialogflow, these are entities that you should pick up. And these entities are defined here. So I'm looking for a country, and the country can be, it has to be a country code. I'm looking for a date, and I'm looking for a temperature. So these are the three entities I'm looking for. So if I say something like, what's the hottest temperature in 2015, for example, and if I don't specify the country, Dialogflow will warn me and say, okay, which country? So by specifying these entities, I'm basically telling Dialogflow what to expect, and it will basically make sure that what it expects is being said by the user. So as you can see, it's very simple. You just define your agent, your intents, and what your intents are supposed to handle, and give some examples, and then it just works. And from then on, you basically just go through the fulfillment, and the fulfillment on the cloud will handle it. So that's what Dialogflow is in a nutshell. Let's go back to the presentation. Yeah, and then from here on, so once we have the request in Dialogflow, it will go to the Google Cloud, and now Ian will talk about Google Cloud in general. Before we get into that, maybe we can ask people like if they use Google Cloud. I'm curious. Yeah.
Does anyone use GCP, Google Cloud Platform? One Google employee and 2 other people? All right, so hopefully we'll convince you to use it by the end of this talk. It's a great platform. So what is Google Cloud Platform? It's basically just a compilation of services. We have everything from compute, big data. We have SQL, NoSQL databases, some awesome machine learning. Of course, we have network and security. The big data we'll dive into with BigQuery that intent Meta was talking about with the hottest temperature in some country during some time. We'll show you how fast it is with large amounts of data. I'll talk about the Vision API, which is pretty cool. We can analyze images, see what's in them, look at landmarks, things like that. And this slide, when I give this talk, I love talking a lot about this slide, and Meta doesn't. For some reason, he just doesn't like this slide. So how many people here are .NET developers?
Wow.
Yes. All right. How many of you use Visual Studio? Okay. You see that? Everyone.
Yeah,
Everyone likes. Who hates Visual Studio?
Some people.
Is that serious? Okay, maybe it is. So what my team focuses on at Google is we make sure .NET developers have a great experience on the Google Cloud Platform. So we have libraries. Who here knows who John Skeet is? All right, everyone does. So Google Cloud Platform has C# libraries handwritten by John Skeet. So you all know they're amazing, right? And then you have my team. We work on tooling. So almost as amazing, but not quite. We have an extension for Visual Studio. So you're able to deploy your applications with one click straight to the cloud. You can browse resources, logs to source, errors to source, see all sorts of things like that in your native environment without having to leave and go to some other console, even though our console is much better than AWS's, and we'll show you why in a bit. We also have tools for Java developers, other things like that. I'll show, given that everyone literally raised their hand when I asked who was a .NET developer. You guys probably don't care about that. We also have integrations with PowerShell. So if you want to script things, you're welcome to do that. So what do we have to offer on the compute side of things? Compute Engine. So this is just raw VMs. So we allow you to create Windows, Linux, whatever you want, whatever size you want. I think last time I checked, you could have a machine with 96 cores and 600 and something megabytes of RAM if you really just want to go all out and have a massive machine. We support that. And you see this thing on the bottom right below Compute Engine, which is the Cloud Launcher. This is kind of our solution for making sure you have a machine all set up. So what happens, we have a ASP.NET launcher, and what that does is it'll launch a Compute Engine Windows machine, and you can add IIS and open all the right ports for web deploy and things like that, RDP, so you don't have to worry about the setup. One click, it's deployed, it has all your software. We have SQL too, Microsoft SQL, so you can get all that stuff on one image. Now on the other end of the spectrum, we have Cloud Functions. Here, who knows what Cloud Functions is? Okay, again, the Google employee and a few other people. Who knows what Lambda is? Okay, more people. It's like that, but Google's version of it. So Cloud Functions, you can just define a small piece of code, some trigger, some hook to hit that, and it'll run your code. Right now, all we support is Node, so you can use your JavaScript. However, in the future, I don't know how far in the future, we'll support C# for sure, possibly F#, other languages. And in the middle, we have Kubernetes and App Engine. Who here knows what Kubernetes is? Okay, more people, good. So Kubernetes Engine, Meta will talk about this a little bit more, but basically this is just a managed version of Kubernetes. We manage the master, you can have clusters, deploy, so you don't have to worry about as much, but you can still configure your application, all your usual Kubernetes configs. App Engine, who here knows what App Engine is? Okay, that's the most hands I think I've ever seen raised at once. So this is a more managed version. You deploy your application. You don't even need to have a Docker file if you don't want. You just deploy it. We handle everything for you. It scales up, scales down. It's always on. It's always running. You just deploy code. You don't have to worry about anything else. So this is a great way to get started with a project a lot of the times. As the project grows, it gets expanded. You need to have more configuration, more control. And then migrating to Kubernetes is a good choice. So I think that's it. So now Meta is going to talk a little bit more about .NET containers specifically on the Google Cloud Platform.
Yeah, so is anyone running on containers here today? Who's switched to containers? A few people. Okay, I want to mention this because we are running the app in a .NET container, so I just want to briefly mention what kind of support we have for .NET containers. Then we're going to get into cooler stuff with machine learning and BigQuery, but we have to go through this so that we are all on the same page. What is a container? I think everyone knows this by this time. It's basically a container is just a lightweight way of virtualizing your application. So instead of virtual machines, you virtualize your process and its dependencies. And because what you're virtualizing is much smaller, it's much more lightweight. It's very easy to deploy. It's very easy to share, stuff like that. So containers has been like the de facto way of packaging and deploying applications in the last couple of years. And when it comes to .NET development on Google Cloud, as you know, .NET World is split into two. The .NET Traditional on Windows and the .NET Core on Linux. So because of that split, we also have some split in Google Cloud. So if you are a traditional .NET developer on Windows, then you can get a Compute Engine instance, which is basically a Windows Server VM with all the configuration that you want, and you can just deploy your application there. But if you switch to .NET Core, you can take that, you can containerize it using Docker, and then you can deploy either to App Engine Flex or Kubernetes Engine. And as Ian mentioned, basically you would normally start with App Engine Flex, but if you want more control and if you want to be able to control your container cluster, then you would probably switch to Kubernetes Engine. But it's up to you where you want to deploy it. Yeah, as long as you have your app containerized, it can run in both App Engine or Kubernetes. And in terms of tools, if you probably are using SQL Server, so you can get SQL Server on Google Cloud, on Compute Engine. There's a Visual Studio plugin to manage resources for Google Cloud. There's a lot of .NET libraries written by his team and John Skeet.
John Skeet wrote all the libraries. I wrote all the tools.
Okay. So if you go on NuGet, google.cloud. And search for that, you'll see all the libraries that we have. And then finally, PowerShell commandlets for scripting your access. And an App Engine Flex, what does it give you? Basically, you just create your container and tell Google, this is my container, can you please run it? And you will just use a single command to deploy it. By default, it will deploy to 2 virtual machines, but it will automatically scale up to 20 virtual machines. So you get auto-scaling. You got dashboards for your application for free. Every time you deploy your application, you get a new version of your application. So you can have multiple versions of the same app, and then you can do traffic splitting. So you can split the traffic between different versions and see how they behave. And then Kubernetes, I mean, I think everyone knows about this, but basically it's an open source container management platform. It supports multiple cloud providers, AWS, Azure, Google Cloud. It can also run on your environment as well. And we have something called Kubernetes, Google Kubernetes Engine, which is Kubernetes as a service. So we try to make it really easy to have Kubernetes clusters on Google Cloud. And this is how you get a cluster in Google Cloud. G-Cloud container clusters create, give your cluster a name, and with that you get a cluster with master and worker nodes to schedule clusters. And if you want to resize your cluster, you can do G-Cloud container clusters resize and specify your size, and that will resize your cluster. So it makes it really easy, basically, to get a cluster, resize it, all that kind of stuff. All right, so we went through that really quickly. I just want to make sure that everyone is on the same page. Now we can talk about the cooler stuff like machine learning and big data. But before we do that, maybe we can ask our application where it's running, because I created an intent for my application. So let's see if it works. OK, Google, let me talk to my test app.
Okay, let's get the test version of my test app.
Hi there.
Which platform are you running on?
Running on Google App Engine. Project ID is home meets .NET containers.
OK, goodbye.
So this part scared me a little bit. So,
Hi there.
oh, okay. Not for that reason. Meta and I gave this talk.
Can you say that again?
Maybe I will mute. Yeah.
We gave this
The
talk.
mic's off.
We gave this talk about a week ago at IT Camp, and he brought his Google Home, and I think it's the British version or something, and it wouldn't listen to me. So I just kept talking to it, and it just kept saying it wouldn't understand. So we switched to the American version.
But now this listens too much. That's the problem.
Yeah. So we got that sorted out, thankfully.
Yeah. So what happened here is that when I said where are you running, so it basically got into this intent, and if you look at here, platform describe. So any of these triggers, what environment are you running, what platform are you running on, will trigger this, and then it will go to webhook, and from webhook it will get into our code. But we'll get into our code once we show you the machine learning and big data as well. So let's just go back to our presentation. All right, so it's you now.
Yes.
Yep.
Yeah, so real quick, we can go back a slide. Meta said this is the cool part. I think this is the second coolest part. When we get into the diagnostic stuff, it gets even cooler, and hopefully the engineers in the room will see that. But this part is pretty cool, too. So machine learning, what does Google have to offer? We have pre-trained models, like we talked about before. We're going to show you the Vision API, but we have natural language, we have translation, video even, so you can give it a video, and it can tell you what's happening where in the video, which is actually super cool. And we also have kind of an open model. You can train it yourself. Who here has heard of TensorFlow? OK, good number. So you can use TensorFlow, build your own models, train your own models, and run those. So here's a list of some of the pre-configured models we have for you. As I mentioned, vision, intelligence, cloud, natural language processing, all things like that. All right, so now we're going to go back to this demo. I think we need to make sure and turn this on again. Actually,
The mic's back on.
Okay, I'm kind of scared now. But we'll go to, before we get into that, we'll give you a quick demo of what the Vision API has to offer. So with any good Vision API, what do you need? Cats, right? So we're going to show you, this is an image of a cat that will eventually pop up here, I think. There we go. So as you can see here on the right-hand side, it's telling you what it is with what certainty. So with 99% certainty, it's saying this is a cat. It's also a pet, a mammal, animal, even says it's a British short hair. I can't confirm that, but I'll take its word on that. Domestic short hair. You can even see the breakdown of the color in the images, and there's a small chance that this is a spoof. However, I'm not convinced that it is. Other cool things we can do here, we have a road sign in, I believe this is probably Australia, I think, because there's a kangaroo on it, if I remember right. Yeah, there's a kangaroo, so probably from Australia. And you can see here it even parsed out the text in the sign. So you can see exactly what is in the sign. Again, the color breakdown, and for some reason this also might be a spoof. I'm not sure why. And one of my favorite things about this is when we get a group of people, it can do detection. Detection in the fact that it can detect people in the image, but not necessarily like one person. So this isn't, if Meta and I took a picture and put our picture up here, it's not going to say Ian and Meta. It's just going to show that there's people there. So for example here, person 1.
If you can turn this on.
We got to turn that on there. Person 1, right here, I'm guessing this is maybe person 1 here or there, does not have any facial expressions. However, person 2, I think this is person 2. Oops, I broke it. Person 2 here, labeled here as 2, is joyful. And you can go down and you can see that there's emotions, so that's picking up the emotions from the people. And then person 7 is only slightly joyful. I don't know why. They should probably be joyful. This looks like a nice picture. And the last one, I think, which is probably Meta's favorite part, if I remember right, is this is a picture. So this, again, it does this detection. It's a stadium. It's a team sports, ball game, athlete, things like that. And again, it picks up text. You can see here on the right from the image. But what it does that's really cool is the landmark is joyful. So it tells you it's Century Field Stadium. So it knows what this is from this image. And it also gives you the location. I think we weren't sure where this was last time, so we had to look it up. Somewhere in New York. Yeah.
So it basically did like landmark detection. So it figured out from the picture that it's a landmark, and if it knows where it is in Google Maps, you can click and see where it is.
Yeah, so that's that for this part of the demo. So now we're going to go back to the Google Home and hope I remember how to talk to it this time. Okay, Google, let me talk to my test app. And of course, my phone lights up too.
All right, getting the test version of my test app.
Hi there.
Let's use the Vision API.
Okay, you can ask Vision API to search for images first. What do you want to search for?
Let's search for images of Oslo.
Found some pictures of Oslo. Now, select a picture.
Select image 2.
Picture 2 selected. You can describe, show landmarks, or ask whether the image is safe.
Describe this image.
This picture is labeled city, cityscape, metropolitan area, skyline, metropolis, urban area, reflection, skyscraper, bird's eye view, and downtown.
Is this image safe?
Let's see. This picture is fine.
Are there any landmarks in this picture?
This picture contains no landmarks.
Okay. Go back to the picture view.
Found some pictures of you.
Okay,
Now,
not quite what I was
picture.
going for. Let's see pictures of London. Okay.
Found some pictures of London. Now, select a picture.
Select image 1.
Picture 1 selected. You can describe, show landmarks, or ask whether the image is safe.
Show landmarks.
This picture contains Houses of Parliament.
Goodbye. So as you can see, it's not quite perfect yet. It's getting there. I couldn't seem to find a good landmark in Norway, probably because of my lack of knowledge of Norway. I'm sure there are some. But just looking for Oslo, I couldn't find one. So some of the things we did here, we asked to describe the picture, and you heard it read back some of the top labels for the picture. We also asked landmarks, which is obviously the landmark detection, which isn't perfect, but it's getting there. And then we asked, is safe? And so what that means is it safe in the context? Is it like a gory image, nudity, medical picture or something? And of course, it also says if it's a spoof, so if it's a fake in some way. So we'll go back to the presentation.
Before we do that, maybe I can show the code a little bit.
Oh, yes.
Yeah. So just to show you how this works, I have it here. So what happens is that, well, first of all, I should probably show the Dialogflow. So when we say, let's go to intents. When we go to Vision API, there's a Vision intro. So when you say, I want to use Vision API, it will basically get into this intent. And then you'll realize a couple of things. Like the first thing is that there's no input context, meaning anyone can trigger this intent. but then there's an output context. So what that means is that once you exit this intent, you will be in vision context. We set contexts because we want intents to be triggered after certain intents. So in this case, it will be vision context that we'll be in. And then if you look at another vision intent, like vision search, for example, for input, it has a vision context, right? So this will only be triggered if we are in the context of vision. So that's how you actually differentiate your intents and kind of nest them in a way, right? So this will be triggered after you are in Vision API, and then this will say, let's see some dog pictures. As you can see, we didn't say dogs. We just said, let's search for images of London. But because we gave this example and because we marked this as an entity that can be anything, that's how it picks up the fact that we are trying to search for London, not dogs. So that it will get it here, and then it will trigger the webhook, right? It will trigger our webhook. So I just want to show you how that works. So if you look at the code, and this code is all on GitHub, by the way. You can take a look at it yourself as well. Oops, sorry. So this is the code, and we have a conversation controller. So this is the main controller that actually, let me make this a little bit bigger. This is the main controller that handles the requests. So it will get into we will get the request here, and it will call something called Dialogflow app. This is an abstraction that I created that handles the Dialogflow requests. So it will get here, it will say Dialogflow handle the request. And if you look at the Dialogflow class, there's a handle request. So the request will get in here. And what we'll do is you either need to create a conversation because it's a new conversation, or you need to get an existing conversation. So that's what happens here. We look at the request, and from there we figure out whether we are in a conversation or we need to create one. But either way, we get a conversation, and then we pass the request to the conversation. So now, if you look at the conversation, it has a handle method. And in here, we need to find who is going to handle this request, right? And the way we do that is that every request has an intent. So it comes from an intent that we define in Dialogflow. What we do is we match that intent to a class, a handler class on the server. And the way I do that is that if you look at the intents, and if you look at the vision search, for example, at the top of the class, I have this intent tag, and I am marking it with vision.search. So this mark is matching the intent name that I define in Dialogflow. So that way, I'm matching the intent on the Dialogflow to the class that I have on the server. That's how things match. And then once it gets here, you'll realize that I'm picking up the search term. So this is the search term that gets passed by Dialogflow. And then I'm just doing a Google search here. So I won't bore you with the details, but basically I create a custom search client. And then from here, I pass in the term, and then I get some images back. And then Dialogflow app has two methods. One is show, the other one is tell. Show shows it in the web page that we have. So it passes some HTML, basically. And then tell just makes Dialogflow to say it. So you're just passing some string to say to Dialogflow, and Dialogflow will say that for you. So that's how we search the images. But in terms of Vision API, like when we say describe this image, it gets handled here in Vision Describe Handler. So as you can see, this is also marked with intent. But it will get here, and then the first thing that you'll realize is that we are using John Skeet's library. So google.cloud.vision v1, so that's the NuGet library that we are using. And what we do is we create a Vision client, and we call detect labels async. So this is label detection. So we are making a single call to the Vision API, and we are passing the image that we had, and then this will give us some labels, and then we'll just order the labels in some way, and then we'll just let Dialogflow say what those labels are. But as you can see, we're using machine learning with just one call. And if you look at the safe handler as well, it's the same thing. We have the Vision client, but the call is different. Instead of label detection, we are calling detect safe search call. So it's, again, a single call, but it's a different kind of call. And then if you look at the landmark detection, again, we create the client, but then the landmark detection is detect landmark. So that's how you use Vision API. I think the next thing that we want to show you is BigQuery. Who here knows about BigQuery, uses BigQuery? Anyone? A few people, yeah. So BigQuery is Google's massively parallel data warehousing solution. And the idea of BigQuery is that you basically point your data and BigQuery ingests that data. And then from then on, you run SQL queries against it. And the key thing is that BigQuery is fully managed, meaning you don't have to create a cluster. You don't have to worry about scalability. You just ingest your data and run your query, and BigQuery will store it in a special format, and it has a lot of compute power behind it. And when you run the query, it knows how to split the query into multiple parts, and it knows how to run them in parallel. It knows how to combine them. And the key thing is that this happens really, really fast. So for terabytes of data, you can actually get results back in seconds instead of like hours and stuff like that. So just to show you how this works, in Google Cloud, there's a BigQuery console. So it's here. And BigQuery comes with some public data sets. So we, for example, ingest everything on GitHub. So everything that happens on GitHub, we ingest that every night. Same thing with Hacker News. Everything that happens on Hacker News, we ingest them. And we provide them as like public data sets on BigQuery so you can play with it. Because I think you get like 1 terabyte of BigQuery search per month for free. So you can play around with it for free. So what I wanted to do is that I wanted to search Wikipedia as well. We also ingest Wikipedia. So I wanted to search some articles in Wikipedia that has the keyword Bangalore, because I was giving this talk in Bangalore. So let me just find the query first. Query history, save queries, yeah. Yeah, let's do this. So what I'm doing is I'm running against the Wikipedia datasets that's publicly available on BigQuery. But the thing that I wanted to do is that, so Bangalore, if you know about it, it has 2 names. Bangalore is the English name, and Bangalore is the Indian name. So I wanted to match both those words in Wikipedia. So what you can do in BigQuery is that you can say, OK, this is the dataset that I'm interested in. But you can also do regular expressions. So in this case, I'm looking at the title of the Wikipedia articles, and I'm matching Bangalore or Bangalore. So I'm doing a regular expression match. And as you know, doing regular expression matches with big data, it takes a long time. So let's run this in BigQuery and see what we get. So this is a regular SQL query, as you can see. There's nothing special about it. And then it just completed. So we finished the run in 6.7 seconds, and we processed 220 gig of data, and that was pretty quick. And as I said, like it's fully managed, so I didn't have to worry about machines or scaling up or down. Everything is fully managed for me, and then we get the results back. So that's the kind of stuff that you can do with BigQuery. So in our application, what we wanted to do is 2 things. First, we wanted to search some Hacker News and see what are some popular Hacker News. So we were using the Hacker News public data set. But at the same time, we also wanted to do, we have the global temperatures of all countries from the, like I don't know since when, like for a long time. So we wanted to see what are the hottest temperatures of certain countries and do a query on that. So let's just go back to presentation. Yeah, so I think at this point I need to show you the actual app. So let me open the page. So this is the page. OK, Google, let me talk to my test app.
Sure, here's the test version of my test app.
Hi there.
I want to search for Hacker News.
Okay, you can ask BigQuery about top hacker news or global temperatures on a certain day.
What was the top Hacker News on May 1st, 2018?
Scan 666 megabytes in 4.6 seconds. The top title on Hacker News was titled, Amazon Threatens to Suspend Signal's Oz account over censorship circumvention.
That's why you don't want to use Amazon. Anyway, what happened is that it ran the query, got the results, and displayed it. And I will go through the
Say
code.
that again?
OK, so I'll go through this, and then we'll talk about it.
I couldn't hear what you've just said. Say that again?
What was the hottest temperature in Norway in 2015?
Scan 5,236 megabytes in 3.1 seconds. The hottest temperature in Norway in the year 2015 was 27.7 degrees Celsius at the NOTODDEN monitoring station.
OK, goodbye. I think I'll
Turn off the mic.
yeah. Well, yeah. I'll just do it just in case. Yeah.
The mic's off.
All right. So what happened in this case is that let's talk through the Hacker News first. So if I go back to the code. No, I guess I should show you the intent again. So we have the intents, and the first intent is BigQuery intro. So in this case, I'm just saying I want to search for news. This will trigger BigQuery intent, and this will set the context BigQuery. Then once I have this context, if I want to do Hacker News, again, I'm saying what was the Hacker News yesterday. And as you can see, the yesterday is an entity. And this entity, it's a date, right? So that's what we are expecting. If I say what was the top Hacker News and that's it, then Dialogflow will tell me what's the date. It will ask me the date. So it requires, because this is a required entity that we're expecting. So once we have this, it will trigger the web endpoint that we have, and then it will get into Google Cloud. And if you look at the Google Cloud, we have the BigQuery intents. So I have a base handler that does the base stuff that we expect, but what I want to look at is the Hacker News handler. So it will get in here in this class because of this intent matching at the top, but then you'll realize that we are using Google Cloud BigQuery NuGet package, which is also John Skeet's, right?
Which
or
one?
Is it yours?
No, Mike Dower, actually.
Okay, some other guy worked on this, but it works great.
John Skeet reviewed all the code, so if that makes you feel better.
Okay. So it will get in here, and then it will pick up the parameter that Dialogflow passed in, the date. And then just like Vision API, in Vision API we created a client. In here we are also creating a client, but this time it's a BigQuery client. And then you need to get the table. The table is the public data sets that I mentioned. So the public data set is Hacker News data set that we have. And then I'm just doing a regular SQL query. So this is the regular SQL. You pass in the parameter, which is the date. And then show query shows the query on the web page. So that's how you can see it on the web page. Then we do a stopwatch so I can see how long it takes. And we run the query like this. It's an async method. And then we get the results back. If there's no result, we say it. But otherwise, we get the results, and we also get some statistics about the results. So that's how I can get the stats. And then I show the query again with the stats. And then I tell Dialogflow, can you talk about some of the stats? So here I'm saying scan this much data in this many seconds. So that's how you do it. But at the end of the day, it's basically getting the client and then finding the table you want to search for and just running a SQL query. And everything else is managed. And if you look at the global temperature one, it's very similar. Again, it's a BigQuery client, but this time the table is different. It's this table. And then from here, the SQL is a little bit different, obviously, because it's a different table. But the rest is pretty much the same kind of code. So that's how you can use BigQuery from your applications as well. And the last thing that we want to talk about is it's great that you have your app running in the cloud, but you need to maintain it. Like you need to monitor it, log it, debug it, trace it. So for that, we have Stackdriver, and Ian can talk more about that
So
now.
again, this is the best part of the talk, just so we're clear. Before we go on to that, I want to make a quick note about BigQuery. So in a previous life, I actually worked on the infrastructure for BigQuery. It's based on an internal, it's not based on, it's basically there's an internal tool called Dremel, and that's what Googlers use to analyze all their data. And BigQuery is like the exact same thing. There's just a public client over the top of it that you can use so external customers can use it. So you're running the exact same thing we use internally. The cool thing, I don't know if you guys noticed or pay attention to the times. So when Meta ran a 220 gigabyte query, and it took 6.7 seconds, I believe, and it involved regular expression. So 6.7 seconds, and we ran a query over, what was it, 500 or 5,000 megabytes. It took about 4 seconds. So the increase in time as the data set gets bigger, it really doesn't change much. So when you start to analyze terabytes of data, you don't get much past that 5-10 second mark. So you can analyze tons of data really fast. And this is one time in my career I'd worked on product with 1 million+ users, and I thought I'd seen a lot of resources, data resources, and then I worked on BigQuery, and I'm seeing like terabytes of RAM in just one zone or cluster, and it's ridiculous, the amount of computing resources, but it makes it worthwhile, and it's so easy for you to be able to analyze all your data. So now we can actually get to the best part of the talk, Stackdriver. So here, who here knows what Stackdriver is? Google employee, 2 other people. All right, so Stackdriver is Google's monitoring solution for external customers. So we have things monitoring, logging, debugging, error reporting, trace, all the things you need to be able to figure out what's going wrong with your application right now, alerts when things go wrong, and what happened to my application X time back.
And it's worth to note that it works not with just Google Cloud, but with AWS as well. So you can use it as one place to look at all your cloud resources if you have them on AWS and Google Cloud.
And although I haven't tested it, other people have said it works. It can technically work on Azure. Anywhere. This is just a library, so you can use it anywhere that you have a Google credential. Someone actually, I gave a talk in Seattle, and they're now trying to write a blog post on how to use the stack driver debugger, which we'll see in a bit, on Azure App Services. So hopefully that'll work out. It won't be too hard. Maybe it will be, and we'll see what we can do about that. So let's do a quick little test here. Let me go to the error reporting page. We'll turn this back on. Hopefully it doesn't.
By the way, the mic's off.
Thanks.
To turn it back on, slide the switch on.
All right.
The mic's
there we
back
go.
on.
So let's go to, so this is our cloud console. So see how nice and pretty, it doesn't look horrible like the AWS console. I'm sorry, that's so hard to use. So let's take a look real quick here. We'll actually start, before we get into using this, we'll go to logging. So here you can see all your services. We'll go to logging. This is actually not the right app, is it? There we go.
Yeah.
So you can see here we have our GAE application, default service, and we're actually using version 4 right now. So we'll pull this up. So you can see logs from the system, from all sorts of things. But the best thing we have here is if we go to ASP.NET Core. So let's look at logs from ASP.NET Core. So this is all the logs from your ASP.NET Core application. We do cool things like this for you. So if we look at our labels, who knows what a trace identifier is? Who's had to use this for debugging? Less people than I thought. So this is a Microsoft construct, or an ASP.NET Core construct. And basically, this can give us all of the logs for a request. So we tag these in our logs so you can see that. So this is something we made sure and built into our ASP.NET Core application logging. So this is actually done, we'll look at the code in a bit, is done with one line of code. You get logging, error reporting, and tracing. So now that we see the logging, we'll go into the error reporting. This is where we get to actually break the application intentionally, and hopefully it will work. So error reporting, this is our error reporting console. So this gives you, perfect. All right, so you can see all the exceptions we've thrown throughout time. There's these timeout exceptions, which are just when we're doing the long polling. And then the argument null exception, which is when we're going to try and break things real quick here. You can see the last time it happened was 7 minutes ago. I don't know if that's right. Maybe we accidentally broke something halfway through our talk. So, hey Google, let me talk to my test app.
All right, getting the test version of my test app.
Hi there.
Throw an exception.
My test app isn't responding right now.
Good.
Try again soon.
So that's what we wanted. So we wanted the test app to not respond. So now if we go here and we refresh this page, oops. Okay, it's not showing up. That is not good.
Yes, I mean, sometimes it takes a little bit of time to show up.
So it might take a second for it to show up. We can look at a past example. We'll wait for it to be propagated. So here's an example of the exception that was thrown before. And you can see here, this is actually that's pretty large. Can everyone read that okay? Yes, no? No? Okay. I'm saying head shaking no. There we go. How's that? Is that better? Good. Okay. So you see here we have this line of code right here. This is from, looks like his dev machine, and it leads you to where it happened and a line. So when we click on it, we can go straight from our error into the code, right where it is, right where it happened. So this is from the intent. Actually, let's go back real quick. Yes, that's, yeah, okay. So this is where the intent happens. So this is actually when we got a null exception here when we tried to do an action. And so what happened, how did we get to this line of code? Whenever you deploy something to App Engine, Kubernetes Engine, we do something and we call generating a source context file. So that basically takes your Git repo and your commit hash, and it throws it in with your application. So when we're looking at logs, when we're looking at error reports, when we're debugging, we can see that piece of code and point you right to it so you can jump around easily in your code. So this is actually a good segue. So this UI, you can see at the top right here, is called the Stackdriver Debugger UI.
Do you require the source code to be on Google?
That's a very good question.
Can you repeat the
They
question?
asked,
Can
sorry?
you repeat the question?
Yeah, they asked if the source code has to be on Google, and no. Actually, this source code is hosted on GitHub. So this is that Git repo that Meta was talking about at the beginning of the talk that is open. So oddly enough, in a previous life, I actually wrote this UI, so I'm pretty familiar with it. So right now, we can see here that there's Meta's repo. It's actually a private fork of it, and a commit hash. So we know that because we've authenticated with GitHub before, and basically we can allow GitHub we can just pull in the files from GitHub and mirror them here. If you don't want to do that for your files or somewhere else, GitLab, Bitbucket, we have support for that. So once you authenticate with Bitbucket or GitLab, you can get your files in. And if you're not doing any of that, or you're on-prem, for example, and you don't want to upload your files, and you don't trust Google to keep your stuff around, we have something called local source. So local source just puts the files in your browser and reads them from your browser. So it's never actually uploaded anywhere. And you can just select a directory, and it'll upload all your files there, and you can debug there. So there's no need to have your files stored on Google. We obviously support our Google internal Google Cloud Source repositories, our Google repos, GitHub, Bitbucket, things like that. Does that answer your question? Awesome. All right, so again, this is the Stackdriver Debugger UI. Who knows what that is? All right, 2 Google employees. My feelings are hurt. So this is like my favorite thing ever. This is a project my team's been working on for about a year. And what this is a forensic distributed debugger for production. So what that means is with every application you deploy, we deploy next to it a small little agent that's running next to your .NET code, .NET Core code. And you can set a breakpoint. So not necessarily a breakpoint, think of it more as a snapshot. It just takes a picture when that breakpoint is hit. It has pretty much negligible overhead to your code. So when you're running, you can have about a maximum 10, 20 seconds, milliseconds of extra latency to your request. So what's user noticeable latency is, I think, 200 milliseconds. So adding 10 milliseconds to a request when it's being processed is pretty negligible. We do less than 10 megabytes of RAM and less than 0.1% of CPU increase when you're using this. So this is, again, my favorite part because I think it's awesome. So we'll do a quick demo of this. So this is our code. And we'll set something here in the conversation controller that will always get hit. So here we have handle async. I think you talked about this already, right?
Yeah, that's the place where all the requests go through, yeah.
So if we don't throw an exception, we should land here, and we should always return something. So now what happened here is you can see here, waiting for snapshot to hit. So this is now, if this is on 1 instance, 2 instances, 3 instances, whatever, it's set on all those instances, and it's waiting for this to be hit on one of them. Whichever one gets hit first, we return it back, and we stop watching the other ones. So let's give this a try. Hey, Google, let me talk to my test app.
All right, getting the test version of my test app.
Hi there.
Let's use the Vision API.
Okay, you can ask Vision API to search for images first. What do you want to search for?
Images of cats.
Found some pictures of cats. Now, select a picture.
Goodbye. So what happened there? We searched for images of cats. We started going through the execution caught that we had a snapshot set in this line of code. And we have variables in a stack frame here. So you might look at this and say, okay, variable 0, variable 1, that's not as useful as I want it to be. That's because this is a release build. So some of the things are optimized out of your release build, but we can normally grab as much information as possible. We can normally grab method arguments. You can see this, since we're in an async method, we have the state machine. We actually have some improvements already on top of this version that allows you to see everything in the state machine for async requests. We have variable 1, which is actually, looks like this for this method. You can see the exception logger. You can see variable set in the exception logger. So you're seeing private variables. You're seeing a tracer we have here. So all this information is here. You can also, you see down here we have a stack frame. So anything that's kind of has black text is information we were able to grab. As you can see here, like system private core lib DLL. We don't have that DLL. If, for instance, you have that DLL, we can grab information from it. And if you have that source code for some reason, we can also do best effort to try and link that so you can walk through your stack frame. So see down here, we have another part, handle request, move next. So we can actually click on that, and it'll take us right to, just about right to where that came from, was one line off here. Again, this is because it's a release build, so we don't get the exact bits, but we can jump through our code and see if you have things that you have PDBs for and source for, you can jump all around. Another great feature here, so we see this variable 0 is set here, and say, this is just going to be a demo, but say we have user X, and user X, every time they do some operation, it blows up, and you have no idea why. And you want to see what happens when user X is doing something. So we'll say variable 0 equals equals -1. So this is user X. And we can pull up this so we can see snapshot history. So we're waiting for variable 0 equals equals -1. And we also have user Y is 2. So we're going to go back to our test app real quick. Hey, Google, let me talk to my test app.
Okay, let's get the test version of my test app.
Hi there.
Let's use the Vision API.
Okay, you can ask Vision API to search for images first. What do you want to search for?
Search for images of small cats.
Found some pictures of smart cats. Now, select a picture.
Goodbye. I didn't quite want smart cats, but I'm actually kind of curious what that would have showed. Okay, that's kind of amusing. So we have some smart cats, although we don't care about the smart cats. You can see here there's 2 breakpoints. One of them was hit. And now the UI is freaking out on me. Oops. There we go. So here's that first one I set where I said the variable equals to -1. That was hit. And we have here variable equals to 2. It's not hit, and it will probably never be hit in this context. So you can easily pick out exactly what you want, what conditions you want. You can get pretty specific with this, so you can grab the right things. So we're just about out of time here.
Yeah, one last thing I want to show you just in 1 minute. And by the way, doing all of this in production code is like very valuable. If you had to debug something in production, you know what I mean. But the last thing I want to show you with Stackdriver is the tracing. So everything that all the HTTP calls that you make, they get traced. So for example, our UI uses long polling to get updates. So you can see that there's a long polling endpoint. And once you click on it, you can see where the time is being spent. If you look at our conversation, maybe it's not here.
You can just search for conversation there.
So you get like a conversation, and under here you can see like what's being called. So under conversation we have Dialogflow app, conversation, vision search, stuff like that. So you get all the timings and everything for free, and it's just very easy to enable this and get it by default.
Yeah, real quick, let's show the code for this actually if we can.
Yeah, if you want.
Just to show you how wonderfully easy this is. So I lied. Most of the libraries are written by John Skeet, who actually walked into the room, so everyone can awkwardly look at him. But a couple of them were written by my team, and of course someone named Mike Dower, who I mentioned previously. That is the wrong thing. Right here. So here, this is the one line of code right here. So this, use Google Diagnostics, and you pass it your project ID. Actually, if you're running on App Engine or Kubernetes Engine or Google Managed Service, you don't have to pass it your project ID. You just say, use Google Diagnostics. And that automatically for you sets up all the logging, error reporting, and trace. And for now, we ship the debugger as a image. So you can see here, normally you would say .NET run. And in this case, you say start debugger .NET run.
Great. Yeah. So I think that's all we had, and we only have one minute.
I did the. Sorry.
Yep.
Other way. You got to go the other way.
All right, there we go. I just want to finish it off.
Okay.
All right, that was it. Thanks very much. As I mentioned, all the code is on GitHub, so if you want to get them, we have a survey. We'll appreciate if you fill it. We don't have time for questions, unfortunately, but we have a booth here, so we're going to be at the booth. So if you have any questions, please stop by at the booth, and we'll be happy to answer any questions. So thanks very much.
Thank you.